Hello and welcome back. In this video we are going to take a look at the measures of center and spread. The basic idea is to represent a bunch of measurement with just one number. So take an example. Let's pick some apples from the supermarket. Here are 3 of them and let's weigh them. So this one is 305 grams, this one is 400 grams, and this one is 360 grams. And now try to find some typical value of this set of apples. And let's try first with arithmetic mean. What do I mean by arithmetic mean? It's x bar, this is the way it is usually denoted, equals 0.305 kilograms plus 4, actually it's 0, let's keep them in grams. Okay, so it's 0.5 plus 400 plus 360 divided by 3 equals 355 grams. And if I tell you that an average apple that I bought is 355 grams, you can get a pretty good idea what apples do I have in my basket. Okay, so this example works fine for the typical value of the apples. Now let's imagine a different scenario. Let's say that I have pumpkins on my garden, and I have different sorts of pumpkins. So I have the decorative ones, the edible ones, and this giant pumpkin. And if I go to the garden and pick 3 of them, one of them this decorative one, and one to make a soup from. So let's say this one weighs 0.5 kilograms, this one weighs 1 kilogram, and this giant pumpkin weighs 100 kilograms. Okay, so what's the average value for this set of vegetables? X bar equals 0.5 plus 1 plus 100 is 33.8 kilograms. Okay, now let's think a little bit about this so-called typical value. Typical value. So the pumpkin actually has no typical value, because this 33.8 kilograms does not tell you anything useful about this set of pumpkins. So what to do in such a situation? It looks like that we cannot represent a set of these pumpkins with just one value. So we discovered that 33.8 kilograms is not a good value to describe a pumpkin's dataset. There is no typical pumpkin. And because of this, we will have to find some other solution how to describe the dataset with less numbers. So let's add another number that will represent the deviation of particular values from this average value. And let's write it in the following manner. So we have now 0.5, this is x1 minus the average pumpkin weight plus 1, this is x2, minus 33.8, which is x bar, plus 100 minus 33.8, and this is x3, and this guy here is again x bar, and divided by 3. Okay, so we have this deviation, the first, the second, the third, and if we calculate the value of this expression, we are getting 0. We are getting 0 because the negative deviations and the positive deviations cancels out. So how to get out of this problem? We could, for example, take an absolute values of those terms, but mathematicians usually avoid absolute values just to make something non-negative, because it does not have the beautiful mathematical properties that, for example, squaring has. So instead of taking absolute values, I'm going to square each deviation. So square this one and this one and this one. This expression has a name, and it's called variance. Variance. And the value of this particular one is 4930 approximately. It's also called mean squared deviation. And why is this? I will show in a moment. So if we generalize this formula, we can write it down as a variance equals 1 over n times I to n xi minus x bar divided by nothing more. Yes, it's just deviation, this thing here, it's called deviation, and it's squared, and we know this expression to be mean. It's not a mean expression, but you get a point. And there is one more thing. So the units of measure are kilograms squared, and this is pretty strange unit of measure. So we may fix this by taking a square root of the variance. So the square root of variance is usually denoted with with S, or with sigma if we are talking about the population value, and it is called standard deviation. So in the end, what do we get? We get a pair of values for our pumpkin dataset. The first one is 33.8 kilograms, and the second value is 70 and something, 70.22 kilograms. And it says that an average deviation from this average value is 70 kilograms. Let's summarize it. We were talking about measures of center and measures of spread. The basic idea is to replace a large set of measurements with just one or two numbers. So the first number was a measure of center, and we used arithmetic mean to measure a typical apple. So arithmetic mean. For the pumpkins, we used, besides the arithmetic mean, also a standard deviation. Standard deviation is a square root of variance, and variance is mean squared deviation. Deviation means how far away particular measurements are from the center of this data set.